Our test tomorrow is 13 questions. I'm going to give you the unit circle, but that's it. So you guys need to know your derivative and integral formulas. I picked certain questions from the review that I want to go over. If you guys have other questions, I'll do those too at the end. So starting with 13, you guys had a question similar to this on the quiz. So this is just find the derivative. We could either move the 5x to the top and make it 5x to the power of -1, and then use the product rule. I'm going to leave it like this and just use the quotient rule. So you could do it either way. So quotient rule is low, d high, so 5x times the derivative of our numerator. What's the derivative of secant x? Secant tangent, great job. Low d high minus high, so secant x, d low. What's the derivative of 5x? 5, perfect. So I'll put that here. Over the denominator squared, so 5x squared. We're squaring the 5 and squaring the x. So this would be 25x squared. A couple different ways we can simplify this. One way that you need to simplify, since we have a common factor in all of our terms, I've got a 5, and I can take a 5 out of 25, is we have to pull out that 5. So I'm going to divide all 3 of my terms here by 5. We're left with x times secant x tangent minus secant over 5x squared. If we wanted to pull out a secant from the top, you can. You don't have to, because it's not going to cancel out with anything from the bottom. But if you wanted to take it out, you could rewrite it that way. You can't cancel out an x because we aren't multiplying the second term up top by an x. You can't take out that x that you're taking the secant up. That is secant x, not just x. So this is as simplified as we can go. 14, we did this with the quiz review. It was on the quiz and people still got it wrong. Are we doing the product rule here? No, we are subtracting. So this is not the product rule. We're subtracting, so we're just going to take the derivative of each term. So what's the derivative of 3x? 3, perfect. Minus the derivative of 5 cosine 2x would be 5 times the derivative of cosine, which would be sine, negative sine, yep. So negative sine of 2x. Times the derivative of what we're taking the cosine of. So what's the derivative of 2x? 2. So then we can just multiply our coefficients that we have here. So this would be 3 minus, actually this would be plus because we have 2 negatives. So plus 10 sine of 2x. Let's look at 18 on the next page. So here we have cosine of the tangent of x. So we're going to have to take our derivative here using the chain rule. So we're going to take the derivative of the whole thing. So the derivative of cosine would be negative sine. So negative sine of tangent of x times the derivative of the inside. What's the derivative of tangent of x? Secant squared x. Times the derivative of what we're taking the tangent of, which would just be 1. So the derivative of x would just be 1. So this would be our answer here. This would be our derivative. Any questions here? Yes. It'd be different if this was cosine of x times tangent of x. This would be the product rule. But here we're taking the cosine of the tangent of x. So because it's in that parentheses, that's what we're taking the cosine of. It's the chain rule. Let's say that this question was similar to 19, where it asked us to find the slope. Let's say it asked us to find the slope at 0, comma, we'll just call it 0, 1. So I would plug in my x value. So we have negative sine of the tangent of 0 times the secant squared of 0. Let's copy and paste our unit circle in here so we can use it. Tangent of 0 would be y over x, so that would be 0 over 1, which would be 0. So tangent of 0 is just 0. But then we have to find the sine of 0. Sine of 0, we look at the y value. So sine of 0 would also just be 0. So this is negative 0, which is just 0, times secant squared of 0. So secant, let's go to 0. Secant tells us that it is 1 over x. So 1 over 1 would just be 1, so that's 1 squared. And 1 times 0 is 0. So that would be our slope, if it asks us for the slope here. So you'd want to work the inside out, so we'd have to find what the tangent of 0 is first, get that value, and then find the sine of that value. Any questions there? Let's do 19. We want to find the slope of the tangent line at pi over 3 comma 0. So first thing we need to do is find our derivative. What's the derivative of sine? Cosine x, perfect. So we're going to take our x value, plug it in. So we're looking for the cosine of pi over 3. Let's go to our unit circle. Pi over 3 is here. Cosine tells us we look at the x value, so that would be 1/2. So our slope would be 1/2. The next question goes with 19. It says find the equation of the tangent line. We're using our point slope form. So y minus y1 is equal to m times x minus x1, where this is our x1 and y1, and this is our slope. So we just need to plug everything in. So y minus 0 is equal to 1/2 times x minus pi over 3. We can simplify and put it into slope-intercept form. Let's distribute here. So y equals 1/2 x minus pi over 6. So with our limit questions, first thing we always want to try is direct substitution. Keep in mind, this will come in handy on the test, if you have either 0 over 0 or undefined over undefined, when you use direct substitution, you can use L'Hopital's rule, which is when you take the derivative of your numerator and you take the derivative of the denominator and then try direct substitution again. So there will definitely be some questions on the test where you are going to want to use L'Hopital's rule. 20 is not even a fraction, so we don't have to worry about that. So first thing we want to do is try direct substitution. Let's plug in pi over 6. So we have pi over 6 times the secant of pi over 6. Let's go to our unit circle and find what the secant of pi over 6 is. So secant goes with cosine, so that would be 1 over x. So 1 over square root 3 over 2. So we'd keep change flip here, keep the top, change multiplication. Flip it to 2 over square root 3. So 2 over square root 3 times 1 would be 2 over square root 3. So we've got pi over 6 times 2 over square root 3. When we multiply here, 2 goes into 6 3 times. So we get pi over 3 square root 3. And you need to rationalize. Can't leave this as your answer. So let's multiply our numerator and the denominator by square root 3. So we get square root 3 pi over square root 3 times square root 3 would be 3, so 3 times 3 is 9. So square root 3 pi over 9. Or if you wanted to say pi square root 3 over 9, that's fine too. All right, let's do 22. 22, we know that the limit as x approaches 0 of sine of x over x is what? 1. Great job. Got to know that. So here, because we have the 3 in our denominator, we know that this is going to be 1 over 3. If this was the limit as x approaches 0 of sine of 5x over 2x, what would our limit be here? 5 over 2. Perfect. We know this. I'm going to show you a different way to work it out. You don't have to work it out this way, but just to practice L'Hopital's rule, we're going to work it out a different way. So we know the formula. You can do it this way every time. You can just look at it. But let's just say if we didn't, if I were to plug in 0, sine of 0 would be 0 over 3 times 0 is 0. So since I get 0 over 0, I can use L'Hopital's rule. So I would take the derivative of the numerator and the denominator separately. What's the derivative of sine of x? Cosine x. What's the derivative of 3x? 3. From here, we can plug in 0. What's the cosine of 0? 1 over 3. So we get 1/3. Same answer that we got here. Again, you can just look at it and you know for these types of questions, but if you forgot what the sine of x over x is, use L'Hopital's rule. Take the derivative of the numerator and the denominator. But this only works, you can only do this if when you use direct substitution, you get 0 over 0 or undefined over undefined. Let's look at 23. So with 23, looking at it, we have sine of 2x. You may think, oh, I want to use my double angle formula, but I don't remember my double angle formula. So let's try something else. If we plugged in 0, if we use direct substitution, I have the sine of 2 times 0 would just be the sine of 0, which is 0. We just did that. Tangent of 0 is also 0. So if I get 0 over 0, what could I do? L'Hopital's rule. So I have the limit as x approaches 0. We're going to take the derivative of our numerator and the derivative of the denominator. So the derivative of sine of 2x would be cosine 2x times what? Times 2, perfect. So 2 cosine 2x. The derivative of tangent of x would be secant squared of x. Now let's try direct substitution. If I plug in 0 into my numerator, I have cosine of 0, which is 1. So this would be 2 times 1 over secant squared of 0. Secant of 0 is also 1, and 1 squared would be 1. So we get 2. 2 over 1 would be 2. So from here, after you use L'Hopital's rule, use direct substitution. Remember, if you use direct substitution and get 0 over 0 again, or undefined over undefined again, you can use L'Hopital's rule again. You can use L'Hopital's rule more than once. Just keep taking your derivative. So you guys have asked if you need to know your double angle formulas. You don't need to know them, but you may have a question similar to this one where you could use a double angle formula, but you could also use L'Hopital's rule. So you don't need to know your double angle formula. We did not use the double angle formula here. You may just have to use L'Hopital's rule to help you solve. 26, same thing. When we did this the first time, we did not use L'Hopital's rule. but we can, because when we plug in 0, we get tangent of 0, which is 0, over 0. So 0 over 0 tells us we can use L'Hopital's rule. I think when we did this in the quiz review, we changed tangent to be sine of x over cosine of x times 1 over x, which we knew sine of x over x was 1. And then we used direct substitution. Our answer ended up being 1 because 1 over cosine of x, 1 over cosine of 0 is just 1. 1 times 1 is 1. But if we didn't want to do it that way, since we got 0 over 0 when we use direct substitution, we can use L'Hopital's rule. We're going to practice it this way. So we have the limit as x approaches 0. Let's do our derivative of tangent would be secant squared over what's the derivative of x? 1. Great job. So secant squared of 0 over 1. Secant of 0 would be 1, and 1 squared over 1 is just 1. So you get the same answer if you do it either way. But remember, you can only use L'Hopital's rule if, when you use direct substitution, you get 0 over 0 or undefined over undefined. You cannot use L'Hopital's rule every time. Like for number 20 that we did, we cannot use L'Hopital's rule there because it's not even a fraction. We don't get 0 over 0. Okay, there we go. Test is a little bit of everything. It is like 4-ish questions on the limit, 4-ish questions integrals, 4-ish questions on derivatives. So make sure you know all of it.
Are we gonna have like the slope?
Yeah, you'll probably see the slope on there. And then I cannot stress it enough, make sure you have your derivatives and integrals memorized. Without those, it's going to be a struggle.
And we need a calculator.
No calculator, but you will get the unit circle. All right, let's take a look at 27. So I'm going to find the integral of sine squared of 3x times cosine of 3x. So here, when our trig function is squared, this is like saying sine of 3x squared. When you have a trig function in parentheses with an exponent, especially if you have the derivative of that trig function, you want to use your substitution here. So we're going to make whatever's inside of those parentheses our u. So let's let u equal sine of 3x. So then du would be the derivative of sine of 3x, which would be cosine of 3x times what? Times 3. Don't forget to take the derivative of what you're taking the trig function of, and then dx. So we've got a cosine x dx, but we're missing that 3. So if I put a 3 in here, what else do I have to do? Put a 1/3 on the outside. We got to keep this balanced. So now I have 3 cosine of 3x dx, and I'm going to plug in my du into that. And then sine of 3x is going to get substituted in, u is going to substitute in there. So we have 1/3 times the integral of u squared du. Because remember, this is sine of 3x squared. Now let's take our antiderivative here. We add 1 to the exponent, divide by the new exponent. So that would be u cubed times 1/3. Times the 1/3 that's already there. What am I missing? I still need to plug in the x back into u, but what else am I missing? Plus c, perfect. So we can simplify and substitute back in. So 1/3 times 1/3 would be 1/9. And then sine of 3x cubed plus c. All right, let's do 28. So with all of your integration questions, if you can make it just the trig function and x or trig function and u, we can use our formulas. So here I've got cotangent of x squared, where it's the x that's being squared, not the cotangent. So I want to make this x squared u. So x squared is u. So then du would be what? 2x dx. So I've got an x and dx there, but I need a 2. So if I put a 2 in here, what else do I have to do? Bless you. Put a 1/2 on the outside. Perfect. So we've got 1/2 times the integral of 2x dx. I'm going to substitute du into there, and then this would be cotangent of u du. Because the x squared, I'm substituting the u into that. This is our goal each time, is to just get the trig function of u du, because we can just use our formulas from here. So the integral of cotangent of u would be 1/2 just stays outside, but this would be the ln of sine of u plus c. The last step, we want to substitute our x's back in. So we have 1/2 times the ln of the absolute value of sine of x squared plus c. One more thing with 28, make sure you know the difference when your variable's squared versus the trig function squared. If this was cotangent squared of x, this is like saying cotangent of x squared. So if the trig function's got the exponent, the whole thing is being squared. Here it's just the variable, so it's cotangent of x squared. So these are different, not the same. So like for 31, our trig function's being squared because the secant has the square. So here when I'm doing my integral, I want to integrate each one of these separately because I have a formula for secant squared. The antiderivative of secant squared is what? Which trig function, which derivative gives us secant squared? Tangent, perfect. So I'm going to integrate these separately. I've got the integral of x dx plus the integral of secant squared x dx. So our integral, our antiderivative of x, we add 1 to the exponent, divide by the new exponent. So this would be x squared times 1/2 plus, and we said the antiderivative of secant squared would be tangent. So this would be plus tangent of x. Now we want to evaluate this from 0 to pi over 2. All right, so first thing we want to plug in is the top number. So we're going to plug in pi over 2. So this would be 1/2 times pi over 2 squared plus tangent of pi over 2 minus, then we can plug in 0. So this would be 1/2 times 0 squared plus tangent of 0. Just plug in the top number first and the bottom. So here, pi over 2 squared would be pi squared over 4 times 1/2 would be pi squared over 8. Good. Then we have tangent of pi over 2. We're going to go to pi over 2 on our unit circle. This is where I made a mistake with this question because this would be y over x for tangent. What is 1 over 0? Undefined. You're not going to get a value that's undefined, but I made this question up. So this one is undefined. If it was a value, we'd have to add it to pi squared over 8. I'm just going to work it out as if it wasn't even there, but it'll give you a value. I made these numbers up, not even testing it out, but it'll work out. It won't be like tangent of pi over 2. It would be a tangent of something that actually works. Maybe, if it's tangent. So then let's go to 1/2 times 0 squared. This would just be 0. Then tangent of 0 would be y over x, so 0 over 1, which would be 0. So this would also be 0. So this would be pi squared over 8 minus 0, which would just be pi squared over 8. Plus whatever we would have to add, but tangent of pi over 2 is undefined. So it kind of doesn't really work out, but it'll work out on the test. Any questions here? All right, let's do 32 next. For 32, I can take my coefficient and put it on the outside. If it's just a value that's being multiplied to your function, you can put it on the outside. There's no x's attached to this 3, so we'll put our coefficient out front. So 3 times the integral of sine of x dx. What is the antiderivative of sine of x? Just cosine? Negative cosine, so negative cosine of x plus c. Then we have to make sure we multiply by that 3, so it'd be negative 3 cosine of x plus c. So if you move the constant or the coefficient out front, don't forget to multiply it by your answer. Any questions here? Perfect. Let's do 33. Cosecant squared, we know, is one of our derivatives. We have an antiderivative for this one. Cosecant squared is the derivative of cotangent. So we ideally just want to get this to be cosecant squared of u. So I'm going to make 3x my u. So let u equal 3x. So then what would du equal? 3 dx, which I have. I've got 3 dx, and I'm going to substitute my du into. So let's plug in. We've got our integral of cosecant squared times cosecant squared of u times du. Like I said before, cosecant squared, we have a antiderivative for that. Cosecant squared is the derivative of cotangent, but this would actually be negative cotangent of u plus c. Last thing we have to do is plug back in our x's, so negative cotangent of 3x plus c. Last few that I wanted to do with you guys are the last 4. Just make sure you know your formulas. The integral for tangent of x would be negative ln of cosine of u, or cosine of x. So variable's x here, plus c. 37 for secant of x. This would be the ln, the absolute value of secant of x plus tangent of x plus c. 38 for cosecant. This would be negative ln of the absolute value of cosecant x plus cotangent x plus c. Then 39 cotangent is the ln of sine of x plus c. So make sure you know these. You also need to know sine and cosine. So know your derivatives, know your integrals.